Greetings, math fans. All right, so this is our semester one M408 final exam review packet, and it's a lot of questions, and the video is going to be kind of a long video, and hopefully it doesn't crash while I'm doing the video. Otherwise, you will hear a large cry from me, and you'll know it's me because it'll be just a bad, really nasty scream. But anyway, so let's get started. I'm going to go through it pretty quickly, and hopefully you guys are good to go. Okay, so. First problem, I basically just give you cosine. I would say just to recognize, first of all, this is cosine and this is secant. And you guys should know it's just a reciprocal. So it's negative 13/5. And that's like a 2-second problem. Okay. Next one, I gave you a terminal side angle passing through that point. So definitely make a sketch for all these problems. Okay, 2A, B, C, and D. You know you're in this quadrant here, and this is -4, this is -3, and of course this is 5. And then you guys just know your ratios. This is R over X, and so it's just going to be -5/4, right? Pretty easy. And tangent is the yax, so Y over X, so it's going to be 3/4. And keep going down here. Sine, of course, is Y over R, and that's just going to be -3/5. And cotangent is the xoi, so that's just the reciprocal of 2b, or not 2b, so it's 4/3. Okay, pretty easy. Okay, so the next group of problems, these are quadrantals. And again, guys, I'm giving you guys these different problems here. Of course, they're not the same problems as the final exam, but very similar to just the context. So like this one says cosecant of 180. You should know the cosecant of 180. You should know the cosecant of 90, of 0, of 270. Anything coterminal, you should know all that and all the different trig functions, all right? And remember the way I kind of think about that as I taught you in class, I go with cosecant, I think, oh, okay, that goes with sine. The sine of 180 is 0, so the reciprocal of 0 is undefined. Okay, just that's the way I think, because I only have limited brain cells, so I don't memorize everything. So, even like cotangent of 270, tangent goes from 0, undefined, 0, undefined, and here's 270 here, and of course it's reciprocal of undefined, which is not really reciprocal undefined, but that would be a 0 there, right? Okay, secant of 0, that means the cosine of 0 is 1, so the reciprocal of 1 is 1. Okay, moving on. These are all exact values. Again, you guys should know how to do every one of these problems very quickly. Cosine of 45 is, you guys should know that's root 2 over 2. Sine of 150, reference angle is 30 degrees. And again, you're over here, so it's positive. So sine of 30 is 1/2, so it's positive 1/2. Secant of 210, 210 is here. Okay, the reference angle is 30 degrees. And secant goes with cosine, so the cosine of 30 is root 3 over 2. So if you flip that, it's 2 root 3 over 3. But because it's in that quadrant, it's -2 root 3 over 3. So watch your signs, because there are going to be a lot of sign changes on the final exam. One's going to say positive 2 root 3 over 3, then one's going to say -2 root 3 over 3. And you got to be good to go with that. Okay? Tangent of 300, we're over here. 300, reference angle 60 degrees. Sadly, it's not a 3-party, so it's just root 3. And because we're over in this quadrant here, it's -root 3. Okay, cosecant of 0. Again, that's a quadrantal. And you guys should know sine of 0 is 0, so the cosecant is undefined. Okay, cotangent of 135. Anything with tangent or cotangent with a 45-degree reference angle over here is 1 or -1. In this case, it's negative in this quadrant, so it's -1. Secant of 600. So the first thing you're going to do is you're going to do coterminal, subtract 360. Okay, that's going to give you 240 degrees. So 240 is here. Reference angle is 240 minus 180. So reference angle is 60. And it's secant, so that goes with cosine. Cosine of 60 is 1/2. You're in that the third quadrant, so it's -1/2. But it's reciprocal of that, right? So it's -2. Okay, so a lot of things to remember, but you guys learned all this stuff already. I'm going to add 360 twice. I'm going to add 720 to that, and that gives me 315 degrees. Well, that's a hot day, right? And then your 315 is over here. Of course, it's 45 degrees. and cotangent is negative there, and so it's -1. Okay. Number 5. So these are where you're telling me what the angle is. Okay. So because I say between 0 and 360, I'm going to have two answers for this problem. Okay. And you guys should remember that. So cotangent of 1/2, and you should say, okay, well, it's positive here and here. And the cotangent of what is 1/2, and you guys should know the reference angle is 60 degrees. So then if you're in their first two quadrants, the answers are going to be 60 and 300. Okay? I'm not good with secant of theta is equal to -√2. So I'm going to write this as cosine of theta is equal to the reciprocal of that, so -√2/2. Now I'm good with that. Cosine again is negative here and here. The reference angle is 45 degrees, so that's going to be 135, and then going down is 225. Okay, cotangent. I personally like tangent of theta is equal to -√3/3. Take the reciprocal of that, and then I know it's negative in these two quadrants. And this is kind of nice because woo woo, it's a three-party. So reference angle is 30 degrees, so it's 180 minus 30 is 150, and then 360 minus 30 is 330. Second favorite time of the day. Okay. Next guy here. Let's see. So we're in this quadrant. These two, where sine is negative. Reference angle is 45. Because sine of 45 is √2/2, and so then it's 180 plus 45 is 225, and 360 minus 45 is 315. Okay, and the last one, again, I don't really know that very well, so I'm going to change that from cosecant to sine of theta is 1/2, and sine is positive here and here. The reference angle is 30 degrees. So that means the first quadrant is 30, second one is 180 minus 30, or 150. So 30 and 150. Okay? Not bad. Let's keep going here. List two coterminal angles for each of the following. So basically, remember coterminal just means add 360 or subtract 360, either one. So if I add 360 to that, I get 80 degrees. And if I add another 360, I get 440 degrees. You can bake a good cake with that. Okay? And then 147, again, same thing. Add 360 and add 360. You know, so I think my answer here, I even subtracted 360 because you can do either one, right? So I came up with negative 213 degrees, 507 degrees, and then that other one is 867 degrees. That's a cold day in the sun. Okay? All right. Number 7. If cosine of theta is less than 0 and cotangent of theta is greater than 0, then theta is in what quadrant? So think about it, math fans. Cosine is negative in this quadrant and this quadrant, right? And then cotangent is positive in this quadrant and this quadrant. So where the overlap is quadrant 3. All right, that's cool. What is the reference angle? So now we're not talking about coterminal angles. We're talking about reference angles. And remember, guys, a reference angle needs to be between 0 and 90, right? Really, really important. So don't give me anything other than that. So this is, 229. If you're at 229, you're down here. So basically, it's going to be 229 minus 180 gives me 49 degrees. Okay? All right, cool. And I was just looking at the temperature, so it's 43 degrees right now. So I'm 6 degrees off. Okay. The first thing you got to do this one is you got to add 360 two times. So plus 720 gives me 300 degrees, right? And 300 degrees is here. So to get the reference angle, 360 minus 300 is 60 degrees. So there's your reference angle. Okay. Fill in the blanks. You guys should recognize these are all co-functions. Really, really important. So remember, sine goes with cosine, secant goes with cosecant, and tangent goes with cotangent. That's why they call them co-functions, because cosine, cosecant, cotangent. Okay? And remember, the angles need to be, they're complementary. That means you need to add up to 90 degrees. So that's why sine of 10 is the same as cosine of 80. And tangent of 1 is the cotangent of 89. And secant of 50 is the cosecant of 40. Okay, so that's kind of easy. But just remember, they're complementary, not supplementary. Okay, they're definitely complementary. All right, so these are basically using your calculator. So this first one, I know sometimes people get afraid with that negative. Guys, if I'm asking you what the sine of a negative angle is, just type in your calculator. There's no doing anything weird. It's literally sine negative 23 degrees 17 minutes. Okay, make sure your calculator's in degree mode, of course, and make sure you know where to find everything, the degrees and the minutes, right? That's like the normal place. And second plus, I believe, is the seconds button. Okay, and hit enter and get your answer. So this one is negative 0.3953. This next one, please, this is a really bad thing to do, so I'm going to write it out here. Secant goes with cosine, so I don't want you doing this. This is horrible. Boo! That is horrible. Don't do that. You're going to get actually you're going to get something really close to 1. Because think about it. That's almost 0, right? 1 over 123 is almost 0. Cosine of 0 is 1. So it doesn't make sense to do that. Please don't do that. It's 1 over the cosine of 123 degrees 87 minutes. That's important. Okay, and then you get negative 1.7943. Okay, and same thing with cotangent. It's 1 over the tangent of 105 degrees, and that gives me negative 0.2679. Okay, all right. So these are inverse trig functions, and or not inverse, but they're we have to find the angle. So guys, the deal is you're going to hit second cosine, right, to find out this guy here. So let's just do that, right? So theta is equal to inverse cosine, so we are using inverse cosine, 2376. That's pretty easy, right? Okay, and then we get 76 degrees, 15 minutes, using your DMS button, degrees, minutes, and seconds. Now, this is a little bit different. Oh, by the way, it's between 0 and 90, so we're only getting one answer here. Cotangent, I'm just going to write this as tangent of theta. Now, I can flip this, and the only reason I'm flipping this is because it's not an angle, it's a ratio. So its tangent of theta is 1 over 1.7623. Okay, so then you're doing the inverse tangent of that. And that gives you 29 degrees, 34 minutes. Same thing with cosecant. You should write this as sine of theta. That's a ratio. Sine of theta is 1 over 2.423. Okay, and then you do inverse sine of that, and you get 24 degrees, 23 minutes. And last one, tangent of theta. Well, that's just inverse tangent. So inverse tangent of 1.613, and that's 58 degrees, 12 minutes. Okay, it's not bad. All right, so let's keep moving on here. I guess we already started into, we've been in chapter 2 a long time already. Okay. All right, so let's take a look at the next one. So solve the following triangle, and notice this is a right triangle, so we can use right triangle trig, which is nice. If it's not a right triangle, you have to use law of sines, law of cosines. Okay. So anyway, I give you angle B is 38 degrees. Of course, angle A is easy. It's 90 minus 38, which is 52 degrees. So 52 degrees. And then you got to use a little trig here. I would always recommend, so we know, you could use angle A. Ooh, this is angle A. I would always recommend using the angle that's given, just in case you messed up with angle A. So we're going to use angle B. And if you, and let's see, A is 7. So this is 7. Let me just draw it on here. So if I want to find little b and little c. So if I want to find b first, you got to use tangent, because tangent is adjacent over, or opposite over adjacent. Okay, so tangent, so we're going to say tangent of 38 degrees equals opposite over adjacent. So we cross multiply, b is equal to 7 tangent of 38, and that gives us 5.5. And then I want to find c, So again, I'm going to use the same thing, that 38 degrees, but I'm going to use cosine. So cosine of 38 degrees equals 7 over c, adjacent over hypotenuse. Okay, so we cross multiply and then divide, right? So it's c cosine of 38 equals 7, and then divide by cosine 38. So c comes out to be 8.9. So 8.9 centimeters, I believe, and the other one was 5.5 centimeters. Okay, cool. Keep going. Guys, remember when we first did this, you were very sad because we talked about the angle of depression. Please don't make the goofy mistake, and you know what mistake I'm talking about. First of all, let's just read the problem. The angle of depression from top of the building to a car is 17 degrees. So let's just draw it nicely. Don't draw anything fancy. Building as just a vertical line and going to the car, which is right over here. And please, 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 this is 17 degrees. Okay, a lot of people want to put the 17 degrees right here. Okay, that's really bad. Don't do that. Because you put the 17 degrees there, you get the wrong answer. So if that's 17, that's kind of nice because then this is 17 degrees. So inside the triangle is 17. Remember alternate interior angles. So that's actually pretty sweet. The building's 18 meters high, and they want to find the distance from the base of the building to the car, so that's x. And so basically you're using tangent, right? So tangent of 17 degrees equals 18 over x. Okay, and then we cross multiply. X tangent of 17 equals 18. Anyway, I'm not going to show a lot of work here. You guys can do this. And it's 58.88. So 58.88 meters. Okay. A hurricane pushes down a 50-foot tree, so it leans against a vertical building. So this is what the thing's going to look like. Here's the tree. And it's just obviously drawing triangles here, right? So here's your vertical building. So a 50-foot tree leans against a vertical building. Top of the tree that touches the building is now 20 feet off the ground. So this is 20 feet. It says, what is the angle of elevation of the tree? So this is your angle of elevation. Does that make sense, guys? I hope it does, right? This 50-foot tree is the tree that's laying down, right? This is the 50-foot tree, you know, if you want the 50-foot tree, and that's laying against part of a building. It's just saying, it doesn't say the whole building, but it's okay, it's 20. And so you want to find that angle of elevation, that the theta. And so we're going to do, of course, we're going to do sine, because sine is opposite over hypotenuse. So sine of theta is equal to 20 over 50, and then do inverse sine of that. So theta comes out to be 23 degrees, 35 minutes. Okay, it's not bad. Okay, so 15. The bearing, whoop, whoop, a lot of bearing problems. The bearing from plane X to plane Y is 33 degrees. Okay, so we're going to draw a good old picture here. So we have our bearing line. Boop, boop. Anyway, the bearing from plane X, so we're going to say here's X to plane Y, so that is 33 degrees. And this is plane Y. Okay, the bearing from plane Y, so we're going to draw another bearing line, to plane Z is 123 degrees. So that is this, and this is 123 degrees. Okay, the bearing from plane X to plane Z is 57 degrees. So, I know it's not necessarily the scale, but this is 57 degrees. Okay, so that's all the information let's get. Oh wait, we got more here. The distance from plane X to plane Y is 300 miles. Oh, by the way, this is Z. So this is 300 miles. And you're looking from plane X to plane Z. So we'll call this, basically it's Y, little y, right? For side Y. So a mistake that people make sometimes, they think this is a right angle by where X is, and that's not a right angle unless it actually says it's an east-west line. So really, if I want to figure out this angle right here, obviously you should look at it and you go, oh, well, that's 57 minus 33. So it's 24 degrees. That's that angle. Okay, and then what else can we figure out? If this is 33, isn't this 33 as well? And then if that's 123, isn't this 180 minus 123, which is 57 degrees? So 57 plus 33 gives me, hey, 90 degrees. That's pretty sweet. So it's actually a 90-degree angle there. Okay, but you don't know that until you actually do the calculation. So this baby right here is 90 degrees. Okay, so if I would redraw this triangle, that's what the triangle looks like. I'm looking for y. I know this is 24 degrees. I know this is a right angle, and I know this is 300. So that's actually pretty sweet. Think about it. What do I need now? If I look at angle at 24 degrees, do you guys agree that I can use cosine? So it's cosine of 24 degrees is equal to 300 over y. So we cross multiply and then divide, and we get y is equal to 328.39 miles. Okay, not bad. All right, let's keep going here. Okay, now we get into radians. And just remember, it's pi over 180 or 180 over pi when you're converting. So, 495 times pi, of course, over 180. All right, and that just gives you 11 pi over 4. Some might be calculator, some might be non-calculator. You're not going to get anything crazy with if it's non-calculator, so just know how to do it. So 11 pi over 4, and this is 240. Again, pi over 180, and that's going to give you 4 pi over 3. Now, if you are allowed to use your calculator, just ignore the pi and just do 240 divided by 180 and hit the fraction button, and then put the pi in after it. That's the easiest way to go. Okay, and of course, these are just, 180 over pi. And this is 180 over pi. Okay, so this is 585 degrees. It's a hot day. And 40 degrees, which is probably the current temperature right now. I'm looking over here right now. No, I got 43 degrees. Okay, well, we're close. 3 degrees off. It's not too bad. Okay, so find the exact value. So this is the same thing as before, guys. This is just in radians instead of degrees. So I don't care how, some of you guys thought of, well, you see pi over 3, you're like, oh, it's 60 degrees. And that's fine, because cosine of 60 is 1/2, right? So, you got to determine what quadrant you're in. So, of course, we're 4 pi over 3, so over here. And so the cosine of 60 degrees is 1/2, but then that's negative 1/2. Okay, secant of 11 pi over 6. Again, I'm not good with secant. So I would do cosine of 11 pi over 6. The reference angle is 30 degrees. Cosine of 30 is root 3 over 2, so you flip it, you get 2 root 3 over 3. But 11 pi over 6, you guys should know is here, because this is 12 pi over 6 is over here. So then it's positive, so 2 root 3 over 3. Got to get your signs right, guys. Signs are really important. You guys know that. Okay, 17 pi over 6, bigger than 2 pi, so we got to do coterminal. So you can subtract 12 pi over 6, and I get 5 pi over 6. So the sine of 5 pi over 6, so it's 30 degrees. Sine of 30 is 1/2, and so of course we're in this quadrant as well. So it is positive, so the answer is positive 1/2. Cotangent 16 pi over 3, so I'm going to add 2 pi many times. So I had 6 pi over 3, basically 3 times. So I'm adding 18 pi over 3. So really I get cotangent of 2 pi over 3. All right, so once again, I would probably do something in tangent. So I would say the tangent, if this is a 60-degree reference angle, tangent 60 is very sad. It's just root 3. So I flip it, I get root 3 over 3. So I know my answer is going to be root 3 over 3. But 2 pi over 3 is over here, so it's negative root 3 over 3. Okay. All right, if cosecant is 5/4 and it's between those two values, find cosine. So this is just a matter of drawing your triangle in the right spot, guys, and then knowing what your ratios are. First of all, you're drawing it here between 270 and 360, and cosecant goes with sine. Sine is y over r, so this is r over y, so 5 and -4. Okay, the sine obviously goes with the y, and then this is a +3. So then when I do cosine, cosine is x over r, so it's 3/5. Okay. Same thing, just a restriction here. Now it's telling you it's between 3 pi over 2 and 2 pi, so I know I'm in this quadrant. I know I am. And cosine's 4/5, so cosine is x over r, so it's 4/5. That means this must be 3. So sine is y over r. Oh, it's -3. Woo! Almost made that mistake. Boo! Okay. And so we have -3/5. Okay, very good. One more here. We're in quadrant 3. It's telling me it's in quadrant 3, so just draw it in quadrant 3. And tangent is y over x, so it's 3/4. But be careful; these are both negative. Very, very important. And then find cosecant. Remember, cosecant goes with sine. Sine is y over r, so that's r over y. So, and this is of course a 3/4/5. So it's 5 over -3, or -5/3. Okay, we are humming along. Chapter 4. For each of the following, give the requested information. So let's start and do with graphs here. All right. The amplitude, make sure you give me a positive value. Okay, it's that number there, so it's 3. The period. So remember I said, this is from back in the day, you guys, if you don't remember this, you set this compound inequality between 0 and 2 pi. First thing I'm going to do is I'm going to divide by 2. So 0 less than or equal to x minus pi, less than or equal to pi, and then add pi to all sides. So you get pi less than or equal to x, less than or equal to 2 pi. So the period is 2 pi minus pi, which is pi. It's the period. The phase shift is that number right there. The only time it's not true, remember, with the phase shift is if it's tangent. Then you actually have to set it equal to 0. Like if I want to find the phase shift for this guy, I could just set this equal to 0. I know the phase shift pi, but if I set that equal to 0, the first thing you do is divide by 2, and then you add pi to both sides, and you get x equals pi. So that's just another way to do it. All right, and then the vertical shift, of course, is just this 8 here, so it's 8. Okay. Okay, let's keep going here. Amplitude is 4. Period, so 4x plus pi is between 0 and 2 pi. Subtract pi from all sides, so negative pi, less than or equal to 4x, less than or equal to pi, and then divide by 4. So negative pi over 4, less than or equal to x, less than or equal to pi over 4. Okay, the period is pi over 4 minus negative pi over 4. So it's actually 2 pi over 4 because you're adding them, right? So then it just becomes pi over 2. Phase shift is negative pi over 4. Again, I could set that equal to 0 if I wanted, and you would get negative pi over 4. And vertical shift is easy. It's after, this is the vertical shift. Sometimes we're used to seeing it before, I think, with a lot of problems, but it can be after it as well. It doesn't really matter. But the vertical shift is negative 5, or 5 down, however you want to look at it. Okay. All right. So this one, the period. Remember, 4x is between. This one's between negative pi over 2 and pi over 2. You should know that. Cotangent is between 0 and pi. Gotta know that. Okay, so the first thing I'm going to do is I'm going to multiply by 1/4. So negative pi over 8, less than or equal to x, less than or equal to pi over 8. Please don't tell them, so the period is pi over 8 minus negative pi over 8 is 2 pi over 8 or pi over 4. That's easy. Please don't tell me the vertical or the phase shift is negative pi over 8. You set 4x equal to 0 and x equals 0. So actually the phase shift is 0. There's no phase shift. And then there's no vertical shift either. Okay. Okay, so the period 4x minus pi is between 0 and 2 pi. Add pi. So pi less than or equal to 4x less than or equal to 3 pi, and then divide by 4. Okay, so the period is 3 pi over 4 minus pi over 4 is 2 pi over 4 or pi over 2. Vertical shift, that's at 3 over there. And the phase shift would be pi over 4. Okay, pretty easy, right? State the domain and range of that function. Well, the domain is always, for sine and cosine, it's always negative infinity to positive infinity. And the range, think about like 2 is your baseline, and so then the amplitude is 4, so I'm going to go up 4 and down 4. So if I go down 4, I get negative 2. If I go up 4, I get 6. So it's between negative 2 and 6. Okay, so same idea. Domain is negative infinity to positive infinity. And you're starting at 3, and you're going up 5, and you're going down 5. So up 5 gives me 8, down 5 gives me negative 2. So it's negative, oops, it's a bracket here as well, because you can be that value. Okay, but it's negative 2 to 8. Okay, cool. State 2 equations of asymptotes. Guys, remember, asymptotes is where the function is undefined. So if I'm looking at secant, think cosine. Cosine goes with it. And where it's undefined is where it's 0 in the denominator. So when cosine 0, secant is undefined. So when cosine is equal to 0, that's when secant is undefined. So think about it. Where's cosine 0? Well, here and here. Because cosine of 0 is 1. That's equal to 1. And cosine of 180 is negative 1. So it's these top 2 locations. So what I'm going to do is you're basically, just because this is just an x here, you're going to say x is equal to 90, or think about it in radians. So pi over 2, and x equals 3 pi over 2. Okay. All right. On to number 26. Okay, so basically this is the graphing chapter now. All right, guys. And well, we did some stuff with graphing already, but now we're actually looking at graphs. And I put it in multiple choice format just to kind of give you an idea of like a final exam, of kind of the way to kind of figure out which multiple choice answer is the graph. All right, so let's take a look at the first one. It says, which of the following equation describes the given graph? So you guys should recognize it. Of course, it's 0 to 2 pi. So it's a normal either sine, cosine, tangent, or sine, cosine, negative cosine graph. And you should see that it's, it starts at a maximum. Of course, if it starts at a maximum, it's going to be C, right? Because it's a cosine graph. Okay, positive cosine graph. That's pretty easy. And if it started down here and went the other way like that, of course, that's Mr. Ghosty graph. Okay, that's a negative cosine graph. And then sine, of course, always starts at 0, and that's positive. And if it goes down first, then it's a negative sine graph. Okay, yeah, that's cool. So this one's a little bit different. If you notice, this one is, first of all, it's shifted down, right? If you look at the kind of the, let's just draw a little dotted line here. All right, this is really the dotted line. And so I definitely know it's shifting down 1. So just to kind of help you with multiple choice, it's shifting down 1. So that pretty much means this one's out of here and this one's out of here, because those are all shifted up 1. And these are shifted down 1. So now you have a, you kind of look at it and you're like, well, is this a, it's starting at a minimum. So it's a Mr. Ghosty graph. So you guys should recognize this is a negative cosine graph, okay? So it pretty much gets rid of this one and it gets rid of this one because those are both positive cosine graphs. So now we're down to, is it a 2x or is it a 1/2 x? All right. So if you guys remember back in the day when I taught you that, when I gave you some like a graph and you are able to come up with an equation, this one's between 0 and 4 pi. So I'm going to write this out. X is between 0 and 4 pi. Okay, remember my goal is to get this to be 2 pi right here. This guy has to be 2 pi. So I'm going to divide everything by 2. So you get 0 less than or equal to 1/2 x less than or equal to 2 pi. So remember, our goal was always to get a 0 between 0 and 2 pi. Once you have that, then that's the number that goes after the cosine. And sure enough, that's the graph right there. Okay, so the answer to this one is E. Okay, so be smart about it. You guys are smart kids. Think logically a little bit about what what the graph looks like and the shifting and whatnot, and kind of put it all together. Okay, don't spend a lot of time on it because you obviously have several questions on the final, and you don't want to get stuck on one and spend too much time on one and not finish the final either. All right. Okay, so the next one is again, you got a bunch of different choices. You got 6 choices here of what we want to do, and this is, I don't want to say this is necessarily an easy kind of problem here. Let's take a look at a couple different things here. First of all, if I look at like a specific point here, I can tell you that's a negative sine graph. And if you guys, as opposed to, we can set up a compound inequality. All right. So if I said this was a negative sine graph, that would be D would be a possibility. You guys agree with that? And let's take a look at a couple other things here. Shifting to the left means a positive sign here. Okay, so if you guys remember, if I asked you guys to graph, this is algebra 2, x plus 5 squared plus 8. Okay, this number right here meant I moved to the left 5. So if I'm going to the left pi over 6, that means it's going to be a plus pi over 6 after, or someplace in the parentheses after the cosine. So just to kind of help you guys out a little bit. Okay, so let me erase this so I have a little more room here. So what I want to do is set up my compound inequality. I think it's between, if I said it's between negative pi over 6 and 5 pi over 6, right? That's one period. Let's do that. Negative pi over 6. And you guys were really good at that. When I showed you guys how to do this back in the day. So that's my compound inequality. Again, this is with a negative sine graph. What I'm going to do is, the first thing I'm going to do is I'm going to add pi over 6 to all sides. So I get 0 less than or equal to x plus pi over 6 less than or equal to 6 pi over 6, or pi. So remember, our goal is to get between 0 and 2 pi, so I'm going to multiply this one by 2. That's going to give me 0 less than or equal to 2 parentheses x plus pi over 6 less than or equal to 2 pi. That's exactly what I want, guys. I have 0 and 2 pi, so that's what should go with that negative sine graph. And sure enough, if I distribute that, obviously it's not the right way, but look at it. So I get 2x plus pi over 3, right? 2x plus pi over 3, right there. Okay, but I could have actually, even before I did any work, just recognize this is a negative sine graph is actually pretty good here. You could have also said, well, Mr. Curvis, it could be a positive sine graph if you started here, right? And that's what you kind of have to investigate. But by me doing this part right here, okay, that kind of helped me determine that which kind of graph it was. Okay? Okay, so let's keep going here. Cursor down a little bit. Okay, 26D. This one definitely looks like a Mr. Ghosty graph, doesn't it? So I would say this is a negative cosine graph. But I look at everything here, and this looks like just a normal graph between 0 and 2 pi. But do you notice these all have phase shifts? So it's not quite a it's like I said, if I had to guess without multiple choice, I would have said this is a really simple problem, y equals cosine of x. Okay, but that's not one of my choices. So that's what makes this problem a little bit more challenging. It's not one. So let's think about it. Since it's not that, well, let's look at a shift. Do you guys agree that this is going this way would be a sine graph? So it's a sine graph shifted over pi over 2 to the right. So that means x minus pi over 2. Okay, it's also, if I go up here, it's also a cosine graph, a positive cosine graph shifted over to the right pi. It's also a negative sine graph, right? Starting here going down, a negative sine graph shifted over 3 pi over 2, right? So it's all of those, but which one obviously is working here? So let's take a look at the first one we did, sine of x minus pi over 2. There it is. Look at that. There's sine of x minus pi over 2. Okay, there is no cosine of x minus pi. In fact, if you look, these are all pi over 2s. So it was kind of a waste of time to look over all of these guys here. Okay, so it's actually, it turns out to be this one, a positive sine graph, x minus pi over 2. Okay, all right, so that one's B. Beautiful. Okay, let's keep going here. The next group here, it says under each graph identify which is a tangent, negative tangent, cotangent, negative cotangent, or yeah, negative cotangent. Guys, remember, this is what I taught you guys back in the day. I'm just kind of doing up right hand corner here. All students take calculus. And remember, the reason I did that is because a tangent graph always goes from the bottom left, and a cotangent graph always goes from the bottom right. This way, it goes that way, okay? Obviously in a different location, but just a general idea. So if you look at just a regular basic graph, first of all, if I had to draw some asymptotes, I could tell you that's a tangent graph. Okay, so this is y equals tangent of x, first one. So y equals tangent of x. It's the polite trig function, or the trig function that the Army uses, tanks. Okay. The next one, again, look at my asymptotes here. Here's an asymptote, and here's another asymptote. And again, all students take calculus. Oh, okay, this has got to be a cotangent graph, and it is. So it's y equals cotangent of x. All right, and then this guy here, looking at the asymptotes again, negative pi over 2, pi over 2, it's going right through 0, right? Between negative pi over 2 and pi over 2. So that's typically what a cotangent graph looks like. Starting down at the bottom right, but because it's between negative pi over 2 and pi over 2, it's not a cotangent graph, it's actually a negative tangent graph. So those y is equal to negative tangent of x. That's when you take something back, it's negative tanks. Okay, and then this one, once again, our asymptotes are between, here's 0 and pi, and it's all students take calculus. So this is, it's flipped around because it's negative, right? It looks like a tangent graph, but it's between 0 and pi. So this is definitely a y is equal to negative cotangent of x. Okay, so that was pretty mellow. This next group of problems, the best way to go out doing these problems, guys, is sketch some points here. So you know it's going to be a cosecant or a secant graph. Okay, so you just have to look to see, you know, which is it a cosine or sine. So here I'm going to draw on that one here, and then if I look at that, I'm like, oh, okay. Well, it's starting there. Right, starting at a maximum, so it's definitely a cosine, and it's a positive cosine graph. So if it's a positive cosine graph, that means it must be y equals secant of x. Okay, let's do the next one here. So let's plot a point, 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 point. Okay, so it's this way, then this way, that way, and that way. All right, that's cool. So let's look at the 0. I'm always looking at the 0 to see what's going on. Oh, it's a negative sine graph going down. So if it's a negative sine graph, that means it's y is equal to negative cosecant of x. Okay, next one. Again, plot some points here. There, right, it's always touching the graph. Okay, so it's this way. All right. So again, look, you're looking at, you got to start at the 0 here, right? And you're like, oh, okay, that's a sine graph, right? It's going from the from 0 going up. So it's a positive sine graph. That means it's y equals cosecant of x. That's cool. And then this one, plot some points here. So graph that. Not the greatest graphs in the world. Okay, and then you look at the 0 again, and you're like, all right, so it's right there. Oh, it's a Mr. Ghosty graph. There is the Mr. Ghosty graph right there. So it's definitely a negative cosine. So if it's a negative cosine, that means it's a negative secant graph. Okay, so that's it with graphing. You know, there's actually another video that you need to click on too. It has a little more practice with some of the graphing, so I would definitely watch that. It's also in just another link to a YouTube video, so I would definitely watch that. Okay. Okay. So let us move on here. All right, so this one, I'm really not going to spend time filling this out, okay? You guys should know all these because you might have to plug things in, you substitute whatever. I put it on here because you should fill it in, and this is just literally from Chapter 5. It should probably even in the Google Drive, okay? So everyone should be able to fill this out. So you guys, first of all, it says verify the following, and I even said the final exam won't have any verifying problems, just simplify. Because obviously, how do you verify on a multiple choice test? So, but you should know how to basically, if I give you some trig function, I say which one of these is equivalent, you should be able to simplify using conjugate, using common denominator, sines and cosines, etc. Okay, so that's why having these 4 problems here just help you to practice the different things. Like if I look at this first one here, you're definitely going to do a common denominator, guys. Before I even do common denominator, 1 plus cosine and secant do not go together. Okay, that is, if I would multiply that left side by secant of x over secant of x, and the right side by 1 over cosine, I mean, it's going to look ugly, and you're going to just want to cry. Okay, so what I'm going to do is I'm going to change that 1 over secant to. So watch this. Wait, I need to. Hold on a second. Okay, so I'm going to change that 1 over secant to cosine. So I'm going to get. That's kind of messing up on me. Okay, we'll try this one more time here. Oh, it keeps going up, jumping on the top. So if I have, it's going to go, there we go. Okay, good. Phew. Sine squared of x. I get nervous, guys, because this video is already 47 minutes, and I do not want this thing to die, because if it dies, and I have to read this whole thing again, you're going to hear me scream and cry, and it's going to be bad. And I think I might drop. Okay, so 1 plus cosine of x. And then I'm going to just change that to cosine of x. I'm not even do the equals 1, okay? And so now I'm going to get a common denominator. And if you think about it, I just need a 1 plus cosine of x there, right? So I get sine squared of x. I distribute that plus cosine of x plus cosine squared of x over 1 plus cosine of x. Oh, sweet! Sine squared plus cosine squared is 1, so 1 plus cosine of x over 1 plus cosine of x. And that's, of course, 1 equals 1. We're done. Ha ha. All right, that's cool. The next one is definitely sines and cosines. I'm working on the left-hand side, so sine of x over sine x over cosine of x. And then just rewrite that sine of x times its reciprocal, cosine of x over sine of x. That cancels, and we get cosine of x equals cosine of x. And we are done with that problem. Okay, pretty easy. 31. So I would definitely work on the left-hand side first because it's adding and subtracting. I think it's more complicated. So that would give me, I would write this in terms of sines and cosines. So 1 over cosine of theta minus cosine of theta. And then get a common denominator. So I'm going to multiply this by cosine theta over cosine theta. So I get 1 minus cosine squared of theta over cosine theta. And that's sine squared of theta over cosine of theta. And then I'm going to split it up to sine theta over cosine theta. And so sine over cosine is tangent of theta. So that takes care of this guy, and then times sine of theta. And so we're done. Okay? That's equal to that. Okay, cool. The next one, I would definitely work on the left-hand side first, because remember, it's more complicated to have 2 denominators than 1 denominator. I can easily rewrite that 1 over sine plus cosine over sine on the right, but at the bottom, I have to multiply by its conjugate, which rhymes with conjugate, of course. So I'm going to multiply this one by 1 plus cosine of x over 1 plus cosine of x. So I get sine of x times 1 plus cosine of x over 1 minus cosine squared of x. And the beauty is 1 minus cosine squared of x is sine of squared of x. So sine of x, sine of x, 1 plus cosine of x over sine squared of x. So that cancels that, and I'm done. Oh yeah. Okay, so yeah, I kind of showed you a couple different ways to do these things. Okay, let's keep going here. Find the exact value of the sine of 285. So what I always told you guys to do is, it's kind of complicated. You need a reference angle here. So there are two things I told you guys to do. First of all, determine the SIGN. Please do not mess up with sines, because if you mess up with sine, I can guarantee you on the final exam, one answer is going to be like 1/2, one answer is going to be negative 1/2, and obviously it's like 50-50 chance. But why even mess it up? You guys should know sine of 285. First of all, we're over here, so I right away know my answer is negative. So that kind of helps you with multiple choice. Then now you know the answer is going to be negative. All right. So remember what we're going to do is we're going to find a reference angle. So we get the SIGN, and then we're going to find the reference angle. So it's 360 minus 285. That's going to give you 75 degrees. So my new problem is negative sine of 75 degrees. That's my new problem. So you got to remember sum and difference. So it's negative sine of 30 plus 45. Okay, and then you got to use your sum and difference for sine. So remember, this is your sine of A plus sine of B. Okay, so I'm going to put a negative here. I'm just going to put a little bracket around here. And remember, it's sine of A, so sine of 30, cosine of B, so cosine of 45. Same sign, so that's plus here. So it's plus cosine of 40, or cosine of 30, sorry, cosine of 30, sine of 45. And you just got to simplify all that. All right? So sine of 30 is 1/2. Cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 is root 2 over 2. So distribute that, you get, you keep the negative on the outside, so I get root 2 over, they're all over 4 because you have to have the same denominator. If it's not the same denominator, you did something wrong. So it's basically root 2 plus root 6, but then it's negative. So make sure you distribute the negative. So it's negative root 2 minus root 6 over 4. Okay? Not bad. So this next one's kind of a weird looking one, but basically you're using cosine of A minus B. A just happens to be X, and B is pi over 2. Okay, so you guys should know cosine, it's cosine of A, so cosine of X, cosine A, cosine B, cosine of pi over 2, and then opposite sign plus sine of A, so sine of X, sine of pi over 2. That's how you simplify it. I'm literally just plugging those values into the A and the B. And you guys should know cosine of pi over 2 is 0. So that's 0. That means the whole thing is 0. And sine of pi over 2 is 1. 1 times sine of X is just sine of X. So it's sine of X is my final answer. Okay? And this next one, same thing, but it's sine of A plus B. Okay, so we're going to do sine of X, cosine of 56 degrees, and then same sign plus cosine of 56 cosine of X, sorry about that, cosine of X sine of 56 degrees. Okay, and you can't do anything with it. That's the answer, right? You can't simplify cosine 56. Okay, all right, sweet. Let's keep going here. All right, so this is a triangle problem. You guys, you remember, you got to draw a picture for each one of these, and then you got to use the picture for each one. Okay, so this is, of course, for A, and this one is for B. So first of all, I'm drawing in quadrant 3. It's because it's telling me it's in quadrant 3. And make sure your signs are right. I cannot stress it enough. Signs are super important for these problems. So it's the yachts, so it's 3, 4, and of course these are both negative, and this is a 3, 4, 5 triangle. And this one's telling you it's between 3 pi over 2 and 2 pi, so it means I'm in the 4th quadrant. And cosine is X over R. And so this is going to be 12, 5, 12, 13 triangle, but of course that's negative 5. And then we just kind of pull everything off. Sine of A is going to A, so sine is y over r, so it's negative 3/5. Okay, so I'm going to kind of scoot this down a little bit, but I'm not going to be able to see this whole time. Cosine is y over r. For B, though, it's negative 5/13. Cosine of 2b, please don't just multiply by 2b. You have to remember you're going to either use 2 cosine squared of b minus 1, 1 minus 2 sine squared of b, or cosine squared minus sine squared, which it's pretty rare that you use that one. Okay, so if I go to b, and notice I already did cosine, so in case I made a mistake, why not just use cosine? So it's 12 over 13, so it's 2 times 12 over 13 squared minus 1. So that's 144, so 2 times 144 over 169 minus 1. So it's 288 over 169 minus 169 over 169. Right, it's looking a little ugly, but it comes out to be 119 over 169. Oops, wrote too big. 119 over 169. And sine of 2a, that's 2 sine of a, cosine of a. So that you got to pull right off of the equation. I'm not going to scoot it down because you can just look at it. But sine of a is negative 3/5, and cosine of a is negative 4/5. Okay, and so we get 24 over 25. All right, that's cool. Sine of a minus b, again, just write this out really, right? Sine of a, cosine of b, same sign, minus cosine a, or sine of b. So I just pull all that off. I get negative 3/5 and 12/13 and negative 4/5 and negative 5 over 13. Okay, pretty easy. So you put it all together, negative 56 over 65. Okay, and then cosine of a plus b is cosine of a, cosine b, minus sine a, sine b. So we get negative 4/5 times 12/13 minus negative 3/5 and negative 5/13. Put it all together, we get negative 63 over 65. Okay, very good. Okay, next chapter is chapter 6. We're getting there. It's almost an hour video, so hopefully this just keeps going here. Guys, remember with chapter 6, all these, whenever you see an arc, it's got to be in range. Ugh, I cannot stress that enough. So remember, if it's sine, and this is negative pi over 2, by the way, and this is 0, and this is pi over 2, and this is pi. Nothing's ever in this quadrant. So sine and cosecant and tangent are in these two quadrants, and cosine, secant, and cotangent are in those two quadrants, in these two. Okay? So remember that. Arc means it's got to be in the range. Okay, so it's negative, so you know you're going to be in this quadrant. And you're basically saying the sine of what is 1/2? It's 30 degrees or pi over 6, and it's negative, so the answer is negative pi over 6. Okay, cosine, we know we're going to be in this quadrant. The cosine of what is root 3 over 2? It's 30 degrees, reference, so that's the reference angle, which is pi over 6, and since we're in the second quadrant, it's pi minus pi over 6, or 5 pi over 6. Okay. Cotangent, it's root 3 over 3. So remember I told you guys if you want, you could change it to tangent, but you still got to be in the right range here. If I want to change this to tangent, that would be the arc tangent of just root 3. Okay, so we'll deal with all this stuff later, but if remember that means it's a 60-degree angle because there's no three-party. So the so 60 degrees, and which is pi over 3. So the reference angle is pi over 3. All right, that's all I really needed to get off of this. Now let's go back to cotangent. It's negative, and we should be in this quadrant, so it's pi minus pi over 3, which is 2 pi over 3. Okay, you're just changing to tangent just to get the reference angle, that's all. Okay, so what this is, it's the cosine of some angle that I don't know. So remember, when the arc is on the inside, you got to draw a picture. It's tangent, so tangent's down here because it's negative, and then it's the ox. So negative 4, 3, and this is 5. And then you say cosine. Cosine is x over r, so it's 3 over 5, and that's your answer. Okay. So this one is, again, the arc's on the inside, so you're drawing a picture. But then I kind of purposely made this really nasty and super ugly looking, because here's the deal. Sine and cosecant kind of cancel each other out, right? Or they don't really, I shouldn't say they cancel each other out. They don't. So, but let's watch what happens here. You know, cosecant is, when I'm drawing this picture, it's negative down here, and cosecant goes with sine. Sine is y over r, so this is r over y. So it's 59 over y over 23, and it's negative. Now, I don't care what that is, because sine is y over r, so it's negative 23 over 59. And that's your answer. Okay? So number 42 is a completely manual problem. You have to do the sine of 0, which is 0. And this is a quadrantal, by the way. And then you have to say the cotangent of what is 0. Well, remember, tangent is 0, undefined, 0, undefined. So cotangent, let me get rid of these. Cotangent is undefined, 0, undefined, 0. So the cotangent of 0 is 90 degrees, or pi over 2. Okay? So remember, if you see an inverse trig function on the outside, it's got to be in range, just like number 43. 43 has got to be in range. I know my answer's got to be between 0 and pi. Has to be. Has to be between 0 and pi. Okay? So this is a manual because these are two different trig functions. So sine of negative pi over 6 is, well, the reference angle is pi over 6. And we're here. So sine of 30 is 1/2. But because it's here, it's negative 1/2. So my new problem is this. Inverse cosine of negative 1/2. Okay, so this is truly for chapter 2. Okay, and then now we're in this is chapter 6. Inverse cosine of negative 1/2, you're like, well, okay, negative 1/2 is over here. Okay, and then you're going to say, okay, well, cosine of what is 1/2? And you're going to say it's 60 degrees, which is pi over 3. And it's pi over 3, but it's in that quadrant, so it's pi minus pi over 3, which is 2 pi over 3. Okay, this one you can do a little shortcut because it's both cosine. Okay, so first of all, if you put negative pi over 6, I would put an r next to it. It's not in range. But remember, cos is pos. I can actually rewrite this. And it's not, you can't do that with an inverse trig function, but it's saying cosine of negative pi over 6. So it's really this. And guys, that's in range. You could do it manually if you wanted. It always works manually, but this one's kind of nice when you have the same trig function. So the answer to this one is just pi over 6. What? Okay. All right. Still going here. Again, I hope Camtasia does not die. This is solving equations. So the first thing I'm going to do is subtract square root of 2. So I get 2 sine of x equals negative root 2. Divide by 2. So sine of x equals negative root 2 over 2. So you guys should recognize these are two answers, right? You're in these two quadrants. The reference angle is 45 degrees. So, and this is all in terms of radians. So it's pi over 4. So if I'm over here, that's going to be 4 pi over 4. So one more is 5 pi over 4. So 5 pi over 4. And the one over here is going to be 2 pi minus that. So 8 pi over 4 minus pi over 4 is 7 pi over 4. So 5 pi over 4 and 7 pi over 4. Okay, this one's always the tricky one. So if I'm going to add sine of x to both sides, so I get cosine of x equals sine of x. And then I divide both sides by cosine of x. So sine of x over cosine of x is tangent of x equals 1. And where is it positive in these two quadrants? So this is going to be pi over 4 And this is 4 pi over 4 plus 1 is 5 pi over 4. Those are your answers. Okay, so that's good. I'm going to pause this. Well, you won't even notice I paused it. Okay, I had to clear out the Word document, otherwise it gets too crazy because it's got too much writing on it. Okay, so you guys should see this problem and see a sine of 3x, and you guys should say, this has triple the number of answers. Okay, so technically, sine of what is negative 1? And you guys should say 3 pi over 2. Okay, because we're down here. Oops, I need to put this back into writing mode here. Okay, so you should say 3 pi over 2. So it's basically 3x equals 3 pi over 2. And you guys know because there's triple the number of answers, I'm going to add 2 pi to that twice. So that's adding 4 pi over 2. So 3x equals 7 pi over 2. And 3x equals 11 pi over 2. Okay, and then your very last step is multiply this by 1/3. So I'm just going to write this on the right hand side here. We get pi over 2, 7 pi over 6 reduced, and 11 pi over 6. Okay, pretty easy. The next one, please do not try to factor something out of here. This is not, you guys need to see a sine of 2x. You need to change it into a double angle. Just like this, I see 49 on the bottom here. See that on the bottom left here? That you need to change that to something with cosine of double angle. Please don't do anything crazy and weird. Okay, so I have sine of x equals 2 sine x cosine of x. Now I move that sine of x over, so I get 2 sine x cosine of x minus sine of x equals 0. Okay, I'm going to factor out a sine of x. I get 2 cosine of x minus 1 equals 0. So sine of x equals 0, and cosine of x equals 1/2. So that's two places. It's 0 and pi. All right, and cosine is positive here and here, and cosine of it's pi over 3 is the reference angle, so that's pi over 3 in the first quadrant, and in the fourth quadrant it's 6 pi over 3 minus 1 is 5 pi over 3. So those are my answers. Okay, moving down here. So once again, do not factor anything out of here. That's a double angle, and you guys should recognize, because with cosine, I'm going to do 2 cosine squared of x minus 1 as opposed to the other one, because that was minus sine of x. Then of course you change it into everything in terms of sine. So I'm going to move things around. So 2 cosine squared of x minus cosine of x minus 1 equals 0. And I'm going to factor that. So 2 cosine of x, and this is going to be minus 1 and plus 1 equals 0. So I set these equal to 0, and then I get cosine of x equals negative 1/2, and cosine of x equals 1. Okay, so negative here and here, so the reference angle is pi over 3, so that's going to be 2 pi over 3, and 4 pi over 3. And this one is just at 0, right? Cosine of 0 is 1. Okay, that's it. That's our answer. Perfect. This one, I'm going to move things over, so I get square root of 3 tangent square root of x minus tangent of x equals 0. I'm going to factor out a tangent of x. So square root of 3 tangent of x minus 1 equals 0. So I set each of those equal to 0. And I get tangent of x equals 0, and tangent of x equals 1 over root 3 or root 3 over 3. So tangent of x is 0 in these two locations, 0 and pi. And that is a three-party, so 30-degree reference angle, so it's pi over 6. And it's positive in these two quadrants. So this is pi over 6 here, and 7 pi over 6. So those are your answers, and those are those guys here. Okay? All right, now we're getting into the little stuff a little more familiar, because 7a is from not that long ago. I'm not going to spend a ton of time on this. I'm not going to even solve them all. Maybe I will, I don't know. But I want to draw a picture, because the main thing with these triangle problems, guys, make sure you use law of sines, law of cosines to figure things out. Please check for angles side, okay? Donkey triangles are really important. Look for the second triangle. It's really, really important. If you need review on how to do that, watch the video. Look at that nice note sheet I made for you guys. I made that awesome note sheet for you back in the day of how to check for second triangle. I would definitely look at that and know to do that. So the first thing I do is I draw a triangle because I told you to do that, and it helps to see what you have. So A, B, and C. And then angle A, so I'm just going to mark it. Angle A, angle B, and side C. Okay, so this is angle, side, angle. Okay, so I get my other, this is kind of a nice one. This is not an ambiguous case, so I can get my other angle. Basically, angle C is 180 minus 26 minus 43. So angle C is 111. Okay, that's pretty easy. And then it's just law signs. So 7 over sine of 111, and we'll do A first, so A over sine of 26, and so A comes out to be 3.28. And same thing, 7 over sine of 111 equals B over sine of 43. So cross multiply, and B comes out to be 5.11 cool meters. And 3.28 cool meters. Okay, that was pretty easy. That's an angle side angle. So I think I did in this sheet, I did one of every one for you guys for practice. Okay, I'm getting nervous. It's an hour and 11 minutes for this video so far. Nothing better die in this one. Okay, so let's keep going here. Here's the next triangle. A, B, and C. And so angle A is 37, so let's mark it. Side B is 21, and side C is 26. So this is side angle side. So this is not an ambiguous case. This is kind of nice. So basically, the first thing I'm going to find is side A. I'm going to use law of cosines. That's the only thing I can use. So A squared is equal to B squared 21 squared plus C squared 26 squared minus 2 times 21 times 26. Make sure it's minus. And make sure you use cosine of 37, okay? So A comes out to be 15.65. You want to store that value. You're not really going to have to worry too much about rounding on tests because it's not like they're going to give you one answer that's really close and one answer that's really close as well, okay? All right, so remember, guys, do not find the largest angle with law of sines. Don't do that. So I can tell you right away that the largest angle is going to be angle C because 26 is the biggest side. So don't do that. That would be really bad. Okay. Oh, excuse me. Sorry. So I'm going to find angle B. So find angle B. And so we're going to use law of sines. Or law of sines. So of course this is a stored value. So we're going to say 15.65 over sine of 37 degrees is equal to B, which is 21 over sine of B. So I do all my work. Again, I'm not going to spend the time on it because I want to get going with this thing here. B comes out to be 50 degrees 17 minutes. All right, and then of course our last one is to find angle C, and that's just 180 minus 37 minus 50, 17. So that gives us 92.43. And by the way, guys, if we would have used law of sines to figure out angle C, we wouldn't have gotten 92.43. We would have gotten actually the supplement to that, so 87, 17 degrees, and I've been wrong. Okay? I'm not going to write in the answer blanks. You see it all there. And then, of course, area. Guys, please don't use anything other than area. I'm going to write this on top here. Area is equal to 1/2 AB sine of C. So it's basically side angle side. It's perfect to use for that. So it's, you can say, here, I'm going to write down BC sine of A. Okay? Just because that's what we're given. So it's 1/2 times 21 times 26 sine of 37 degrees. So area is 164.30 meters squared. Okay, so that is a nice side angle side. Okay, let's move on to 53. Let's draw a picture. ABC. So angle A, side B, and side A. Oh, look at that. Brutal. Angle side, side. Hope your parents aren't watching this because they'll see that Mr. Griffiths is putting swear words on there and you're done with the videos. I'm just kidding. Okay. So it's angle side, side. So I know it's the ambiguous case. Okay. So first thing we're going to do is we're going to find, the only thing we can find is angle B. So we have 26 over sine of 30 equals 42 over sine of B. So angle B, do all your work. Angle B comes out to be 53, 52. And then, of course, angle C is 180 minus that. So 180 minus A and B. So I can write it all out. So angle C comes out to be 96 degrees, 8 minutes. Okay, that's easy. And then I can find side C by using law of sines again. So 26 over sine of 30 equals C over sine of 96, 8. So C comes out to be 51.70 meters. So that's our first one. Now we need to check to see if there's a second triangle. So check second triangle. And remember what we're going to do is we're going to do 180 minus that first angle we found. 180 minus 53, 52, which gives us 126.8. And then I'm going to add that to the given angle, so plus 30. And that's 156.8. So it's less than 180, so we have a second triangle. Okay, that's all it is. It's very simple. So our new angle B, we already know is the 126.8. That's our angle B2. And then angle C is 180 minus the given angle that we have up there, 30, minus 126.8, right? So angle C is equal to 23.52. And then to find side C, because you got to find that too, we're just using law of sines. So again, I'm going to use that 26 sine of 30 that I used on top there. So 26 over sine of 30 is equal to C over sine of 23.52. And low C comes out to be 21.04 centimeters. Okay, so again, look over that sheet. That was the best way to do these problems, just make sure you guys know what you're doing. All right, so here's another one. ABC, and so angle A, and side C. Ha-ha! Another square triangle. Or, sorry, donkey triangle. Okay, so we're gonna find side, or angle C first. So it's gonna be sine 10 over sine of 82 equals 7 over sine of C. And we solve that, and we get C is equal to 43.53. Okay. And okay, we're good. And angle B then is equal to 180 minus A and C, which is 54.7. Okay. And then of course, we do, law of sines to figure out side B. So 10 over sine of 82 equals, and of course, this is a stored value. It's going to be little b over sine of that stored value, 54.7. Okay, so B comes out to be 8.18 centimeters, or meters, I guess. Okay, so that's cool. So now we got to check for the second triangle. So check second triangle. So remember, it's we're using C. That's our possible second triangle. It's always the first angle you find. So 180 minus 43.53 So this is angle C, I'll say angle C2. That gives you 136.7. And we add that to the given angle, original angle, plus 82. And I can see right away that's like huge. It's 218 plus degrees. Okay, so that's bigger than 180. So it's only one triangle. One triangle. Okay? Okay, that's cool. And then let's do this guy right here, 55. So draw a picture. ABC, A is 87 degrees, so that's fine. Side A and side B. So, ooh, another donkey triangle. Okay, let's plug it all in. So we're going to do 23 over sine of 87 degrees equals 39 over sine of B, Sinba. All right, and actually, after you do that, you get sine of B is equal to 1.69, and of course this is way bigger than 1, so this is no triangle at all. Can't even be any triangle. Okay? Don't you wish all the problems were like that? Okay. We're getting there, guys. We're getting there. So 56. So ABC, and oh, these are all the sides. Okay, geez. So this is side, side, side. So this has got to be law of cosines to start out. Remember, always find the largest. I mean, obviously, it all depends on what they're asking for on the multiple choice. But you always have to start out with something. You've got to find one of the. If they ask you to find angle B, then you find angle B. It doesn't matter. You can find any angle. So I guess. But we'll start out, if I asked you to find all of them, you certainly would start with angle B. I'm just looking at my answer key here. I start out with, it doesn't really matter. I start out with A. That's cool. Okay, so I get A squared equals B squared plus C squared minus 2BC cosine of A. All right, and so I want to find angle A first. So I'm going to remember I told you guys, solve for the cosine of A first. So if you do that, you get cosine of A is equal to A squared minus B squared minus C squared over negative 2BC. And then you plug it all in. 9 squared minus 17 squared minus 12 squared over negative 2 times 17 times 12. Again, you plug it all in. Make sure you use lots of parentheses here, guys. Really, really important. Hit inverse cosine. And so A comes out to be 30 degrees, 22 minutes. Okay, so that's kind of nice. And remember I told you, don't use law of sines to find the biggest angle. So I guess the next one I did, I probably should have done B first. But now I'm going to find angle C, because that makes the most sense. Okay, with law of sines. So it's going to be 9 over sine of 30/22, which is a stored value, is equal to 12 over sine of C. So cross multiply and take inverse sine, and C comes out to be 42/23. Okay, and then angle B is just 180 minus A and C, so it's equal to 107 degrees 15 minutes. Now the deal is, if you would have found angle B first with law of sines, you would have gotten the wrong answer. Okay. Last thing is that area. You got to use Huron's formula, guys. Okay. So we got to find the semi-perimeter first. So 9 plus 17 plus 12. So the semi-perimeter is 19, and then the area is the square root of 19. 19 minus 9, 19 minus 17, and 19 minus 12. And don't forget to take the square root. Okay? And that comes out to be 51.58 meters squared. Okay. Woo! I think we have, oh my gosh, this is it. Oh, we're so close. Oh, we got a couple bearing problems. Oh, Ryan. Oh, good old Ryan. Ryan starts to walk in a bearing of 31 degrees for 45 kilometers. So let's draw a nice problem here. 31 degrees. So 31 degrees is this way. for 45 kilometers. So it's 45. He then changes course, so put another dotted line here, and walks at a bearing of 137. So this is 137 for 65 kilometers. How far is Ryan from a starting point? So you're looking for this line right here. So guys, we've done so many problems like this. If this is 31, of course, this is 31 here. And if that's 137, this is 180 minus 137. So that's 43 degrees. So this whole angle then is 43 plus 31. So it's 74 degrees. Oh, that's a nice warm day. Okay, and then so if I would draw the picture here, math fans, I would get 74 degrees, and this would be 45 kilometers, and this is 65 kilometers. So we're definitely using law of cosines. So we're looking for this x. So it's x squared is equal to 45 squared plus 65 squared minus 2 times 45 times 65 times cosine of 74 degrees. Don't forget to take the square root, and x comes out to be 68.1 kerfometers. Okay, next one, find the lengths of the diagonals of the parallelogram. So guys, remember this. Here, this is what you're given. You're given one side is 9 centimeters, 1/6, and the angle, and one angle is 50 degrees. So 50 degrees. So you draw your parallelogram, and they ask you to find the lengths of the diagonal. So I'm looking for this diagonal. Let's do that one first. Okay, you guys should know if that's 50, that's 180 minus 50, which is 130, and that's 9. So you guys definitely should know this is law of cosines, right? So if I call this x, so it's going to be x squared equals 6 squared plus 9 squared minus 2 times 6 times 9 cosine of 130. So x comes out to be 13.65. Okay, and then if I do it the other way, I'm looking for, here, let me just kind of redraw this here. Right, this is 6 and 9. So if I'm looking for this diagonal, let me draw it. I guess I can draw that in red. Right, if I wanted that diagonal, that's pretty easy too, because this is still 50 degrees. So I don't even have to do that much. I don't have to, in fact, I just set up law of cosines, right? So it's just x squared equals still 6 squared plus 9 squared minus 2 times 6 times 9 times cosine of 50. Okay, and so x, that comes out to be 6.90. So 13.65 and 6.90. Oh, excuse me. Okay, we're almost done. This hasn't died. It's almost an hour and a half video. Yikes! Okay, I'm not going to do 59. I mean, come on. 59, you just multiply it by 2, and just add that together, and you got 0, 11. That's easy. This one's magnitude, so just make sure you do the magnitude. So it's 4 squared plus 3 squared. Ignore the negatives, right? So 16 plus 9, 25 squared root of 25 is 5. It's pretty easy. Please, it's dot product. So 2, 4, dot, negative 4, 3. Please don't give me a vector. Okay, it's 2 times negative 4 plus 4 times 3. So negative 8 plus 12 is 4. It's a number. Please don't give me a vector. And then that one is just putting a negative in front of it and subtracting, so that you get 2, negative 7. That's easy. Okay, remember I told you you'll see this one on there? You definitely. So you're pushing a 4,000-pound SUV up a hill. Right angle there, it's a 4-degree slope, and here's your SUV, and that weight is 4,000. So I'm going to draw this picture. Let me make it a little bit bolder. And there's your right angle. So this angle right here, guys, that angle is 4 degrees. Okay? And then the weight going down is your 4,000 pound SUV. So if I redraw that triangle here, the hypotenuse is the 4,000, and this is 4 degrees, and you're looking for this force. I shouldn't redraw it, but this right here is this right here. So you're looking for the force, right? The force you're trying to push onto that SUV. So you're using, I'm going to paint this X. So you're basically using, it's right triangle trig, but it's just sine. So it's sine of 4 degrees equals opposite over hypotenuse. Cross multiply, and you get X is equal to 279.03 pounds. And that's your force. Okay? Whew. That's it. So like I said, my recommendation to you math fans is look at the other graphing video with more graphs, and hopefully you guys are good to go. If you know how to do every one of these problems, you should do really well in the final. Guaranteed. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.